everybody. Today I'm going to be going over question 2.21 from the in-class bingo assignment. This problem is dealing with the pitch of a baseball, and so it's talking about the physics that are involved with the pitcher throwing this baseball. And in the problem we're given key information such as the final velocity equals 45 meters per second, the displacement is 1.5 meters, and then from just thinking about it, we know that the initial velocity is 0 meters per second. So doing that, and then also knowing our kinematic equations, and also knowing from the problem that the ball undergoes a constant acceleration. So since it's a constant acceleration, we can use this kinematic equation, and to find that acceleration, all we need to do is to manipulate this equation a little bit to solve for that acceleration. So now what we'll do is plug in the values that we already know and solve for that acceleration. So what we end up with is 45 meters per second squared minus 0 squared over 2 times that displacement. So now what? And that equals the acceleration. And so when we go through and do all that math, we end up with 675 meters per second squared. Accidentally erased this with my arm. Touched that up a little bit. Perfect. Alright, so that means that constant acceleration is 675 meters per second squared, which is pretty fast for a human throwing something. So part A is done. Now all we need to do is part B. And part B wants to know how long that pitch took. So how long that ball was being accelerated in the pitcher's hand. And so we do that because now we know the acceleration. And so since we know the acceleration, we know the initial and final velocities, we can use this kinematic equation that says the final velocity equals the initial velocity plus the acceleration times time. So now all we need to do is rewrite this equation for solving for time. Put the time over here for ease. Alright, so now we know that the time that pitch took to do was the final velocity minus the initial velocity all over the acceleration. Since we already know all these values, the next step is just to plug in what we already know and to solve for that time. So when we plug that in, it'll be 45.0 meters per second minus 0, because that was our initial velocity, over 675 meters per second squared. And when we put that in our calculator, we'll end up with t equaling 0.067 seconds. So what that's saying is that in just under 7/100ths or 7/100ths of a second, that pitch was completed. So not only is it accelerating really fast, but it's also being done in a very short amount of time. So hopefully this helps you to be able to solve this problem on your own. And just to summarize, recap what we've done, we took known values such as the final velocity, the initial velocity, and the displacement, We also knew that the acceleration was constant. So knowing all of that, we found a kinematic equation that gave us one variable that we didn't know, which was the acceleration, and that's what we were looking for. So we changed the equation around to solve for that acceleration, and then just plugged in our numbers to find part A. For part B, to find the time, since we had previously found the acceleration, we could now use the kinematic equation here, that the final velocity equals the initial velocity plus the acceleration times time. Since we knew all of these values except the time, all we ended up having to do was to rearrange the equation to solve for time, plug in the values that we knew, and we ended up with our answer. Thanks for watching, and I'll see you in the next problem.